Welcome to Tordan's Laboratory. Today, in our special highlight, we're going to talk about self-closing doors. I had a request to kind of formalize the self-closing door, so I'm going to go over a couple of bits and pieces. So to kind of give you the end result of what this door is supposed to look like, we have this door here, and I can open it in a number of ways. I can open it with this switch right here, and no matter how many times I click this switch, it always opens the door. I can close it with this switch right here. No matter how many times I click this switch, it always closes the door. So I have one to open and one to close. I can open the door this way, and if I walk away from the door closes. If I click here and the door opens, and I pass through the area detection zone, the door closes. And so this door is one of the designs for self-closing doors that will basically always stay closed. In any given scenario when you're passing through the doorway, I've actually put the detection zone out here for demonstration purposes, but normally we would mount it here above the door. So the point is that if it was mounted above the door, as I pass through the door and leave the detection zone, the door will close. Right now the detection zone's out here, so that's why it's doing that. All right, so we're going to talk about how to do that. Now, there's a handful of pieces to this that make this possible. And the first one is this bit here where we're talking about one button to open the door and one button to close the door. Now, there's actually a whole bunch of reasons that you might want to do this. The most common reason is that if I want to be able to have buttons on both sides of the door that will remember its current state, or if you're doing an airlock, for instance, where you want to make it so that only one of two doors can be open, regardless of what you do. You can't open this door. These are the kind of things that you would want this particular capability and stack them. But without going too far afield, we want to be able to do this. So we're going to do that over here for this door. Right now this door is not attached to anything. It's just sitting here by itself. So what we're going to do is we're going to place a handful of pieces. So the first thing is, of course, we need our switches. So we have two switches. We have one here and one here. And what we want is for this one to open and this one to close it. Now, what I used, there's a couple of ways to do this here. They're called SR latches, or set and reset. All right. And I'm going to show you a set reset latch first that I actually don't prefer for this scenario, mostly because it has, well, let me talk about why. So this is a set reset switch. These are actually NOR gates, or the NOR operator. And basically you go from the switch to the NOR operator, and from the NOR operator to a relay, and then from the relay to a light. And then the other side of the relay crosses to as an input to the NOR gate on this side, and this relay crosses to the NOR gate on this side. And the end result of this is an equivalent thing. If I push this button right here, it turns on this light and turns off this light. And if I push this button, it turns on this light and turns off this one. And no matter how many times I push this button, I can push it a million times and it just turns on this light and turns off this one. So I can get the same result I have over there with the door by simply removing this light, ignoring it completely, and this is my door, right? If I push this one, it closes the door. If I push this one, it opens the door. The problem with using what's called a NOR gate SR latch is that that's what these are called, an SR latch, or set reset latch. And it's a very common electrical engineering construct. It's used in computers all over the place for all sorts of things. This particular structure has one flaw, and that is that you can't push both of these buttons at the same time. If you do, the NOR latch will potentially wind up in an unstable state, or set itself or lock itself into a position. And that can be problematic. Now, normally, because these are buttons, it would be very hard to push, so it would work. But there's a simpler and a better solution. This is what's called an and/or SR latch, all right, or an SR and or latch, depending on how you want to phrase it. Either one would be correct. And it basically uses a similar construct where it uses a not right here and an and right here and an or right here. And it's basically set up this way. If you look at the flowing arrows, you'll see what I'm doing. So the top switch goes, so I threw some extra OR gates on here. You can ignore them. And we're going to build another one right here anyway. So let's build this one. So I've got my switches, right? And I'm going to put an OR gate right here. They call them operators, but in electronics we call them gates. So there's my OR gate. And then I'm going to put a NOT right here and an AND right here and a relay. All right, so the relay connects to the door. Boom, my relay connects to my door. It's going to open and close the door. And then I've got this switch to the OR gate and this switch to the relay. And if I just push it here, it opens the door, and when I let go, it closes the door, right? Because it's a button, not a switch, right? But now, if I take this one and I go to the NOT, and I go from the NOT to the AND, and then the relay goes to the other side of the AND, all right? And the AND goes to the other side of the OR. And that's going to give us that triangle right there. So the OR gate to the relay to the AND back to the other input of there. And this is this NOT right here is just to reverse the polarity of this button. All right. So this structure gives us what we want. If I push the top button, the door opens. And if I push the bottom button, the door closes. And that is always the case in every scenario. All right. Over here, what I did is I just stuck an OR in between the button and the rest of the circuit. And that's so that I can have multiple inputs. This can be useful for a handful of reasons. One is if you wanted to have buttons on both sides of the door. If I put, if I've got this set up so that I've got an open and a close, and I put my open here and my close here, that's all fine and dandy. If I open the door and I want to go through, and again, it's closing on me because my detection zone is over there. But let's say the door is closed on this side. Push the right button. There we go. Right, I've got no button. Can't open the door. Right. If I throw two ORs right here, I can attach more buttons. So I can add another button here, here. Link them to my OR as well. The ORs in this game will take, I think, up to 10 inputs. And I can put these buttons on this side of the door. So now I can open and close the door from either side. I can click here, go through, close the door from this side. Done. I can open the door. All right. And again, the same principle, no matter where I open the door from, as I move away or move through the detection zone there, the door closes, right? The point here, though, by the way, is that the detection zone, which is right here, and if we want to, we could move it here so it's slightly less confusing, right? Entering the detection zone does not open the door, right? I don't want the door to automatically open. I want to manually open the door, and when I'm done and I move through the door, I want the door to close, all right? Regardless of whether I use the switch or clicked on the door or what have you. So how do we achieve all the rest of that? And the answer from here is actually fairly simple. We just create a very simple circuit right here that feeds the close, all right? So what I've done is I've got a NOT and a relay and another relay and an AND, all right? And the detection zone is tied to this NOT right here because I want it to trigger the door to close when I'm not in the detection zone, all right? So we're going from the detection zone to the NOT so that it reverses. So as I move out, it triggers it, all right? And then right here, we have a relay that feeds to a second relay, which feeds to this AND, and the NOT also feeds to the AND. All right. And so the in here goes to the NOT. All right. And what's happening here is that this relay right here is got a delay on it. And it has a delay on it so that it will, to trigger a different thing. So I'm going to build this over on this side so that it's a little bit clearer what's going on. So the first thing, of course, is we want a detection zone, right? So there, we have a detection zone. Now, if I triggered the detection zone on its own to this, so I can't add it to here because I didn't put my OR in there, right? There's no place to attach it to. So we're going to stick our extra OR gates in here so that we have a second way to deal with this. So the first thing I'm going to do is sever this connection, that one and that one, and put an OR there and there, and then we go from here to here, and from here to here, and from here to here, and from here to here. So now we can trigger this with either the switch or something else. And if I tie this right now to this, well, that's all fine and dandy. But if I enter the thing, okay, let's set the, that'll open the door. That'll close the door. If I enter right here, it closes the door. So the state here is if the door is open and I enter the detection zone, it fires the close the door, right? Well, that's backwards, right? I want it to close the door if I move away, right? And so the simple version here would just be to throw a NOT in here, right? So we go ahead and delete this and put a NOT here. Well, okay, so now we link the detection zone to the NOT and the NOT to the OR. And now, if the door is open, well, wait a minute, how come the door won't open? So I have to be inside the detection zone, right? I've got to be there, and then I can push the button, because if I'm not inside, it's forcing the door closed. The moment I leave, it's forcing the door closed. However, it's because this NOT is here and this is here, it's holding the door closed. So if I'm out here and I try to activate this, it forces the door closed immediately. Now I could hold that down and go through the door, and then it would close it, but that's not really the functionality I want. So I'd either have to be standing here so it's not triggered, right? So it's active. See, the moment I move away, it's triggering that close. So I'm inside, it's not triggering the close. So from here, I could conceivably open the door, and then, but then if I move through it, it'll close. But that's really awkward. So we don't want that, all right? So what we need to do instead is have it only trigger the door when I'm inside the space and I move out of it, all right? And the way that you achieve that is by triggering a double state. So basically what we want to have is the trigger to run if I'm in the space and I move away from it. So we need to be both in the space and out of the space simultaneously, okay? Well, we can do that. The way that I did that is by having the rest of these pieces here. So basically what we're still going from this to the NOT, right? But the NOT doesn't automatically go to the OR anymore. So we're going to sever this connection right here. And we're going to say that when this triggers, and I'm going to give you a slightly different version. So there's two ways to get a delay. One way is if you right-click on a relay, you can activate a delayed relay. The other way is there's actually an element. that I don't use so much because the delay is a little bit longer, but it's called a delay. And we'll go ahead and we'll put a delay line in here right now. Because it's longer, it's actually easier to see what's happening. So we're going to put a delay in here. All right. And then we have, so we're going to need to fork this. So we're going to put a relay. So we get a relay. So now what we're going to do is we're going to go from the not to the relay, right? So now it can do two things. And we're going to go from here to here, and then from here to here. And we're also going to go from, but that's not enough, right? We need an and. So we're going to, so from the relay to from the not to the relay to, make sure I'm getting this right, that way to there. I confused myself for a second, but I will get back to it. The and. All right, so when we're inside here, then this is true, all right? And that's how we know that we're inside the area, right? So we're going to go from here. Oh, that's what I did. One sec. Got to trigger the door. I knew what I was doing. Really, I did. Or there. All right. We're going to go from here to the relay. So now we're triggering this, right? When we're here, that is true, right? So when we're inside, that there's a true right here. And this is true when this is true and something else is true. So here to the not, to the time delay, to here. And rather than have it open and close the door for a moment, I'm going to put on a light so that you can see it. Here, and put this on the light, and go from here to the light. All right. So what happens here is right now we're inside, and as we move away, see how it's pulsing the light on? Still got something wrong here. Oh, I did that backwards. It's going to be a lousy tutorial if I have to go back and do it 12 times, isn't it? But we'll get there. So apologies for the correction to the puzzle. So we're going to the relay. We're going to we want the time delay to be on the true. That's what I did wrong. So the delay to the and then no delay on the not, and then from there to light. Right? Right. So I'm in here, and as I move away, the light pulses and then turns itself off again. Because the light is only true, it's only on when I've just moved out, because the time delay says, oh, you're still in, and I've moved out, and that's instantly saying you're out, but the in is there on a delay, so there's a moment of that pause where they're both true. All right. And apologies for momentarily confusing myself, but that's the piece to that. So you're going from the sensor to the relay, and then you're forking. You're going to a delay, to an and then to the not, and to an and. And that way, there's only a moment when they're both true, and that's the delay pause. Now, I don't like this delay because I think it's too long. It's easier to see here. Remember, as I move away, it'll pulse on and hold it for a moment. This delay, I think, is too long for this scenario. So we're going to delete that, and we're going to put a relay here instead. Whoops. That there. And this relay, we're going to right-click on and say Activate Delayed Relay. Delayed relay. And then we're going to rechain that to there and to there. And so now we should have the same result. I move in, I move out, the light should turn on. Let's try that one more time. I move in, I'm inside the area. Let's do that. And then we move out. Oh, did you see it flicker? Right? So as I move out, it flashes. And it's just a really short moment where it pulses, right? But that's what I want. I only want a pulse when I move out from the thing, and that's exactly the result I want. So now I take, let's go back into build mode, take the light out of the circuit, and now I tie this to my OR gate. All right. So now we have a scenario where if I open the door, right, that's all great. If I close the door, that's great. I'm well outside the detection zone. So I can open the door without standing in the detection zone because this isn't holding the door shut anymore, right? Because it only ever is pulsing the shut the door button for that split second when I'm exiting the detection zone. Now I can enter here, and if I open the door and I'm inside the space and I move out, it pulls the door, it closes the door as I exit the zone. All right. Now, that's all fine and dandy, but there's still one scenario we haven't covered. All right. And that scenario is what happens if I open the door this way. All right. Right now, the door is in a state of thinking it is closed. These switches all think the door is closed. So if I enter here and I move away, it does not pulse the out because it doesn't think that it was ever on, right? The off state is assumed in the circuit right here. Well, that's damned inconvenient, right? We don't want that. And so what we need to do is fix that problem. And for that, we need one more relay, all right? So if the door thought that it was in a open state, which I just clicked on, it was already open, but I clicked the open state. Now it knows it's in the open state, and when I move away, it executes the closed state. But I want to be able to open the door this way, move through my door, and have it close, and right now it doesn't. All right. And the way that you solve that problem is there's another quote-unquote feature of this game where apparently things trigger on relays in the order that they were connected in. So if we throw one more relay in here, right there, and we go from here, whoops, helps if I use the right tool. So we're going to our relay, and then from the relay, we're going to go to the on, and then to the off. So now what happens as we move out of the detection zone is it sends a pulse to the open door and a pulse to the closed door. Simultaneously, almost, but a fraction of a second apart. So now, if the door is open, the door will close. And if I do this, and I move through here, and I back away, the door closes. And that is the finished product. All right. And so there's a whole lot of electronics here necessary, but now this door will absolutely close in every scenario where you move through the door and it simply closes, always. Now, the only sort of downside side effect of this is if you listen very closely, I don't know if you can hear that. You see the door will kind of do like a little pulse there when I move away. It's opening and closing the door, even when the door is closed. And that is because by design, I've told it, no matter what, when I move out of this zone, pulse the door open and pulse it and then close it. And that, excuse me, talking without drinking my water. Apologies. So anyway, that is how you do a self-closing door that closes in every scenario using a handful of, well, using an SR and or latch and a self-negating pulse and a open-close trigger. All right. Anyway, thank you very much. This is Tordan's Laboratory, and that was how to make a self-closing door.